As we move toward using more solar and wind energy, battery helps solve a big problem, which is how to store electricity when it's available and use it when it's needed. Battery energy storage market is segmented into front-of-the-meter systems, which we often call as FTM, and behind-the-meter systems, or BTM. These classifications are based on where the storage system sits relative to the electric meter. Front-of-the-meter BESS refers to storage systems that are connected directly to the transmission or distribution network before the electric meter of end users. So looking at this diagram, starting from the generation phase, either in combination with PV utility scale systems or wind systems, all the way to the transmission phase and ending with the distribution phase. The battery energy storage is linked here to high power systems above 5 megawatts of energy. A bulky stationary energy storage containers are being utilized. You will find them working alongside big solar and wind farms with a bulk storage of 1 megawatt to 10 megawatts of energy. While the typical power for solar systems is around 500 kilowatts up to 5 megawatts, and for wind farms from 500 kilowatts to 10 megawatts. These containers are often placed at key points in the grid, like substations, which handle issues like transmission limits or sudden change in power demand, with a power around 500 kilowatts up to 10 megawatts of energy. The power stored in these batteries is not for a single home or business, it's for the entire grid or a big section of it. In this segment, the front-of-the-meter energy storage systems, there are three main values depending on the power level. One is the grid reliability and stability, and the BESS goal here is simply to support the grid, especially as more solar and wind powers gets added. It supports with things like frequency control, voltage regulation, and storing excess renewable energy. They can even delay the need for expensive upgrades to power lines or substations. Second value is the transmission capacity, so the stored energy helps to manage the peak demand or sudden change in power demand. For example, during heat waves when people need to switch on the air condition. Third is the intermittent renewables, and by that I mean that it's not always possible to harvest energy from solar or wind, so you need to bridge this period by using the stored energy when the sun is not shining or the wind is not blowing.